In this video we're moving on to more complex problems involving cylinders and spheres and hemispheres. We're looking at questions where we're given the volume and asked to find a dimension, either the height or the radius. So in this first example it says the volume of a cylinder, it's key to recognise what shape they're given, is 15,840 centimetres cubed. If the height is 35 centimetres, find the radius. So with these types of questions, they're not as straightforward as questions where you're given the height and the radius and you're asked to find the volume. Here you're given the volume and you're asked sort of to work backwards. So the way that we do this is we form an equation to start off. So we know from our tables and formula that the formula for volume of a cylinder is pi or squared h. Okay, and in this question we know that that's actually equal to 15,840. Okay, we're going to leave pi as it is. We'll use the pi button on our calculator. We don't know what the radius is for now, so we're going to leave that as r squared. But we do know that the height is 35 centimetres. Okay, so that's equal to 15,840. So what we're going to do here is we're going to divide both sides. So we want to isolate r, we want to get r on its own. So we're going to divide both sides by 35 pi. And whatever I do to one side, I have to do to the other side. So when I do this, the 35 pi will cancel and we're left with r squared equals 15,840 over 35 pi. And if we want to find r, we're going to get the square root of that fraction. You can put this into your calculator at any stage, but I would recommend leaving it till the end as you'll get your most accurate answer. So if I just put that into my calculator, so I'm going to start off by opening up my square root, fraction 15,840 over 35 pi, and that is going to give me 12.002. So that is just 12 centimetres to the nearest centimetre. Next up we're going to look at problems where we have equal volumes. So we have one shape has a volume which is equal to another shape, and this will also help us find missing dimensions. So to read through the question, first of all, it says a sphere of radius 4 centimetres is equal to the volume of a cylinder with a radius of 8 centimetres. Find the height of the cylinder. So it's similar to the last question, except this time we have to do a step ahead, a step before we start to actually find the volume. So we want to find the volume of this sphere first of all. Okay, the volume of a sphere in the tables is 4 over 3 pi r squared h. Okay, and it tells us here that that's actually equal to the cylinder. So that's equal to the cylinder, and we know that the cylinder, the formula for volume of a cylinder is pi r squared h. Okay, so here what we're going to do is we're going to sub in the different values. So the this is pi r 4 over 3 pi r cubed. I've written in the wrong formula. The radius of the sphere is 4 centimetres. So we're going to sub that in. So you get 4 over 3 pi times 4 cubed. We know that the radius of the cylinder is 8 centimetres. So 8 squared h. And at the end of this question we want h on its own. So we want to isolate h. At this point, to make the question a little easier, we can divide both sides by pi here, and that will remove pi from both sides. So what we're left with then is 4 over 3 times 4 cubed. So I'm going to put that into my calculator. 4 over 3 multiplied by 4 to the power of 3. And that will give us 256 divided by 3. And we leave it as a fraction for now. Then we're going to find 8 squared, which is 64 h. And then to find h, again, we can flip this if we like equations looking like this. And we want to find h. So the way that we do that is we divide both sides by 64. And we can simply just put that into the calculator. So 256 over 3, which is this, and divide our answer by 64. And so h is equal to 4 over 3. and we'll give that in as a decimal. So if we change it to S to D, that will be H equals 1.3 and centimetres.